All right, guys, let's take a look at this thing. So, the huge thing about all of mathematics, you got these formulas that kind of we build out of ideas. So when you have a problem, once you've built the formula, what you really need to get from the problem is all the parts that have to go into the formula. So when you have a binomial thing, there's four pieces you need. N, P, Q, and then X. What does X represent in the binomial?
What you're trying to find.
Whatever you want to like it. The number of successes. N is always the number of things you're looking at. It could be people. And then P and Q, of course, are both what kind of things? Probabilities. So they must desperately be less than 1. Greater than 0, of course, but definitely less than 1. So what's N in this first problem? 22 is crazy. What's P? 0.68. What's Q? 0.32. And in this first problem, X is 13. So then I got 22 people. I'm going to choose 13 of them to do something. So I got 13 of these guys. And then I've got the rest is going to be what? No. All right. So I mean it's my hope that you guys see how that formula kind of sets itself up. Right? You just move the pen and it just does it for you. If only it was that way. And what do you guys get for that? I think you got 1, 6, 3. If you remember what order those numbers are in. All right, so hopefully everybody got that okay. All right, and then we had this interesting discussion about really the at least one is the most general, most come across example of this idea. But the idea is if the opposite situation has less work to do, then I'm going to do that. Because then I can do 1 minus that, right? Less than 21, that's 0 to screw that shit. What's the opposite of less than 21? 21, 22, right? If anybody's not 21 yet, you know what the opposite of less than 21 is. 21 and 22, right? I don't know why you would know that. All right, so then if you do the probability of 21, you do the probability of 22, that'll answer the opposite of what they want. And you should get, I don't remember anymore. It sounded like I remember, didn't it? Oh, no? What do you get? No. Just for this. Can't remember. One of them was going to be 0.0002 because it was like times 10 to the negative 4, right? And the other one was something. Nobody's going to help me. Say again? 0.0021. All right. So 0.0023 total when you add those together. Yeah. So that's the answer to the opposite of less than 21. So I just did at least 21. So I can't circle that shit. That's not the answer to the question. I have to do what to that? 1 minus, because that's the opposite of what I want. Minus 0.0023 is 0.9977. Kick easy assay. Just to show you, why not? I was thinking about whether or not to show you this. Oh, there's a very interesting button down here. Above vars, there's a button that's it's probably distributions. Hello. So if you hit second vars, you get the distributions. Anything look familiar in there? Just a couple things, really, right? A lot of the shit don't look familiar. Before the end of the semester, we're going to talk all the way down to here. Going to stop short of there, which is too bad, but oh well. We're going to get to this, which is called cos square. It's not Dragon Ball Z. It's Greek letter chi. So I see normal curves. There's normal stuff up there. I can make the calculator calculate normal stuff. But if you hit the down button, do you see anything else that looks familiar? Look at that. Binomial. So P is particular. So watch this. If I do binomial PDF, now it's going to look different for those of you that have the older calculator software on your calculator. Yours is just going to say binomial PDF and have a parenthesis. You're going to put in there n, comma, p, comma, x. So which basically what we're going to do. Trials is n, the number of trials. So let's recapture this first answer. There were 22 trials. Probably success was 68. Yeah, there. And the number of successes I won was 13. So if you have the old style calculator, it should look like this. And the answer better be 0.1163. Oh, yeah. Okay. Right? I love how people get interested when suddenly the answer shows up. Wait, you just got the answer. So if you put there n, comma, p, comma, x. So what is the other one? Do you guys notice under distributions there's another one? Binomial CDF. That's cumulative. So that's if I want from 0 up to something. So watch this. If I do binomial CDF 22 trials still 0.68 chance of success, but I want to go less than 21, so I want to go up to 20. Bam. 9977. Yes, maybe. Do you have to know how to do the binomial CDF and P? No, you don't have to, because I'm going to want you to do it by hand anyway. But that's still nice to be able to check it, you know. Right? And if you're upset that I make you do it by hand, then you picked wrong. I'm sorry. There are other teachers that don't teach you shit. You can take them. Yeah, you know you are. All right. I'll calm down. I'm sorry. I'll get a little passive. Is everybody with me so far? Everybody all right with that first problem? Second problem, I sort of start off with another one of these, but hopefully, I mean, how many people total I got? 211. I want to choose 19 of them to do something, so I want 19 of these, and how many for the others?
192.
Yeah, 192 the rest. So what do you plug all that stuff in there? 0262? 0362. Is that what you guys got? All right. So we all got it right. No, I'm joking. That sounds about right. And then I quickly take a turn here. The mean and the standard deviation. These are the best formulas we've seen yet for these things. No table required. Just straight up. When you do 211 times 0.12, you should have gotten 25.32. And then when you do the square root of NP times Q, you should have gotten 4.72. Oh, yeah. Is that right? Okay. Please don't let me steamroll you. You can stop me if something's not making sense. What's up? Sorry.
SEA.
All right. And now here's an idea that you must know. Just to kind of let you know, I think I said this before. When we get to chapter 9, we're going to change the definition of unusual based on the situation. If I am in a nuclear power plant, like I got Homer Simpson's job, I'm sitting there and I actually do the job, and one of my little gauges starts to go towards the red, am I going to wait for it to get in the red before? Okay. I didn't say you. I said me. So now everybody knows who we want to not end up in that job, right? So in the given situation, I'm going to define unusual to not be 2 steps away. I might define it to be 1.5 steps away, or even 1 step away. Because the consequences of something bad happening is huge. I want to kind of make sure I get off my ass before that happens. And in other situations, who gives a shit? So maybe I'll push it out to 3 standard deviations until I care. Because it's like, if this is true, then 1 more cat is born. I don't know. That was a weird situation. Right? It's not, nobody's going to blow up and die. We're not going to have Godzilla come and all that kind of shit. Okay. So right now, our definition for unusual starts 2 standard deviations away. So I put in the middle, I put the mean, 25.32. If I go 2 steps up, where do I end up? 34.7 something? If you go 2 steps down, 1588. That's a good year. So would it be unusual to find 14?
Yes.
Yes, because this is where things usually happen. So if I only found 14, that would be unusual. Outside 2 standard deviations. So that would be an unusually small amount. I like it. So if I say this name, how many people know this? Erin Brockovich. It's a movie that was based on an actual person. She's the one that investigated PG&E because they were putting shit in the water and they were causing people to get sick. So if you did a study and you have the normal parts per million of some kind of substance that's acceptable, like rat feces, how much is acceptable in your hot dog bun? Unfortunately, it's more than 0. Yeah. Yeah. Don't think about that too much, kids. But if I go and I investigate these water wells and I take samples and I see parts per million that is above the expected amount, above the max usual, I'm going to be concerned, right? Especially if I start to see people having symptoms of something. You guys semi with me. So there is an acceptable amount of radiation. There's an acceptable amount of whatever harmful thing, like rat poop. You know. But we can tell what would be bad. You know, how many standard deviations to go out. Are you guys semi with me? So that's a very surface level study to do to see if things are out of whack. Then you get deeper into why are they out of whack. All right. Is this the same situation I gave before? Oh, well. Is it? No, it's not. Okay, good. So draw the distribution. So this is going to go from 1 to 12. How tall is it going to be then? So, right there, when I say draw the distribution, indicating the height, obviously I need the height, but people will do the 1 to 12 and put the height and then not even draw the box. So you haven't drawn the distribution. The distribution is a box. So please put the box.
What's in the box?
Don't look. Just don't. Now, that picture cannot change for this if I suddenly have a question I ask. That's something else somebody does. Somebody will draw this one, 7 to 11, and they make the height become 1 over 4. That doesn't make any damn sense. That is the distribution I'm working with. I have a piece of it to look at now. Right? What's the height of any of these pieces I'm going to look at? 1/11. Let me make it clear. Bam. So if I put 7 to 11 in here, doesn't even matter if I get it in the right place, I don't care. What's the area of that rectangle I just drew? How wide is it? 4. How tall is it? 1/11. So it's 4/11, which is 3,636. The neat thing about dividing by 11 is you multiply the top number by 9 and then you just make that repeat. So 2 over 11 is 0.18181818. And you got to calculate, right? Who cares? All right. What's the probability that I find them within the first 5 minutes? And I had a couple of good questions. Let me draw this again. So I want within the first 5 minutes. So somebody was asking me, do I do 0 to 5 or 1 to 5? And I said, sure. Because either way you look at it, it doesn't change. Because what's the probability it's from 0 to 1?
0.
Nothing. So all that really counts is this. So no matter how you look at it, that's the area I'm talking about. And again, that area just happens to be 4 times 1/11, right? So 3,636. Is everybody okay with that? What about taking me more than 12 minutes? Ain't gonna happen. In this case, for some reason, it takes me at least 1 minute, and at most 12 minutes. I know this is not a reason, I don't care, it's just an example. And what's probably of any individual number in this case? X equals 8, for example? 0, because again, the most easiest answer to that without doing iotas and infinities is the area of a line is 0. Done. So that's 0. I like it. Kick ass. Okay, so uniform distributions, do not let them be difficult. Just don't. All right, so now we're going to get into something else. The big takeaway I want from what we've done is that if I have a picture of a distribution, for example, we're going to get into normal curve. That's why I just did that. And I make the whole area 1, the probability of any question about something in that will equal the area related to that question. So I could do a problem like, what's the probability some dude is taller than 7 foot tall? All right, well, if I know the distribution, I know the mean and standard deviation, I can actually calculate that. Now, what's wrong? Let me get you guys. What is worse about the normal curve compared to the uniform distribution? What's the normal curve look like? It looks like a bell. I like it. Why were these areas so easy? They're all just rectangles. Kick-ass. Basic geometry just eats those up, right? Then I've got something like this. And let's say the average height of dudes is 69 and the standard deviation is 69 inches and the standard deviation is like 2.8. Whatever. I haven't checked in a while. That's what it was last time I checked. Fortunately, it's probably got down since we had a recession and all kinds of things. Life expectancy high. We're up there. Now watch. So I can ask a question that sounds very familiar to there. What's probably some dude is taller than 72 inches, right? Can I find that on the picture? Sure. It's like here. You guys cool with what's happening so far? It's very familiar to what we're doing up there. Do you have a geometric formula for the area of something shaped like that? If you do, I want you to come up here. Okay, I didn't think so. Because there isn't one. There isn't. There is something you can do with calculus. Yeah, dude. So there's a formula for this curve. And if you integrate it, I'm not going to teach you calculus. Don't freak out. But I do want to show you this formula at least once. I think it's in here. There it is. Oh yeah, look at that. That thing is just so pretty. Aw. Stay up there, dude. Go home, formula, you're drunk. Okay. Bam. Alright. Look at that monster and yumminess. So that's the formula. That function, if you actually put that in your graphing calculator, you put in, what is mu? That's the mean. So if you put in 69 and you put in 2.8 for the standard deviation, you guys see that? If you put that in there, it would draw this picture for you. Total. And again, you don't have to know calculus. I'm not going to teach you calculus. But one thing calculus does is it's able to find the area under any shaped curve. That's what it does. If I know the formula for the curve. We're not going to do that. What we're going to do instead is say, hey, calculus people, do some shit for us, and then write a bunch of answers down. So I got a chart that has all these areas on it. Okay. So before I give that to you, I want to see, oh shit. You guys remember a couple things. So this one we can't do. We're going to have to hold off on this. We're going to do this in a little bit. But can somebody tell me, what about between, what is it, Jeff? 66.2 inches and 71.8 inches. There's something special about those two numbers. And if you did the corrections on the first test, it should sound very familiar. There's that liters of beer that different people in different countries drank, right? Remember that problem? And they asked you what's the area, what's the probability it's between this and this, and it was 68% because it was one step. So what's 66.2? Isn't that one step down? So let me do this. Could I, underneath 66.2, I'm going to put -1. What the hell is that -1? Yeah, one standard deviation. It's a z-score. I love it. It's one standard deviation below the mean. So what am I going to put underneath 71.8? Holy shit. What am I going to put underneath 69? 0. Kick ass. Kick ass. Nothing major there, right? Nothing amazing. So there's supposed to be what percentage in here? 68%. All right, so any chart that I give you that doesn't give me this, we gotta throw that shit out. Just to make it a little bit easier on us, if there's 60, let me see who gets this. If there's 68% in there, what percentage of men are shorter than this? If there's 68% in here, how much is outside? 32. So how much is on that side? 16. How do you know they're cut in half? Because it's symmetric around the mean. You guys see how I got 16% here? There's 68% in, there's 32% out. So how much is on that side? 16. Bam! So if the chart I give you, when I look up -1, and it doesn't tell me something about 16%, we're going to throw it out, and we're going to go have drinks somewhere instead of have class. Okay? Unfortunately for you, it's not going to happen. So don't get too excited. You never know. I could go insane. Maybe it's not 16. Maybe I made a mistake over there. Let's find out. Is everybody rooting for that? I understand if you are. So here, look at this sucker. Look at this. This is somebody doing the calculus to figure out all the areas and then writing them all down for me. Because do I need their help for a uniform distribution? No, it's freaking rectangle. I can do the calculus, it's basic geometry. But I need some help for this shit. But does the idea change? The area associated with the question is equal to the probability that question asks for. That's the idea. That doesn't change. It's just that the area of a normal curve much harder because part of it is all curving. All right. By the way, I just want to really make sure you understand this. See that formula up there again? We're never going to use it directly, okay? If you know some calculus, you can ask me about some stuff. If you know any calculus, you should be able to tell that is really difficult to integrate. If you don't, you're fine. You don't have to. We're never going to use that formula in here. All right, let's look at this thing. How the hell do I read this weird ass thing? Well, a couple things I want to point out to you. You're not allowed to have notes on a test, but you notice this thing is telling you what this works for. What kind of distribution does this work for?
Standard normal.
Standard normal. So a normal curve, right? If I don't have a normal curve, can I use this chart? No. Bam. So a big part of a lot of different statistics problems is, do I have something that is at least normal enough so that I can use this? And why is this chart so nice? Because it's all the answers. I just got to find them. So, now watch. Any z-score that you look up, what does this chart tell you? Well, what's shaded up there? No. If I look up a z-score, what part is shaded? Below the z-score. So this will always tell you the area below any z-score you look up. So what if my problem wants a greater than some z-score? Well, I look it up and then I do 1 minus. Holy shit, look at that thing. I like it. So yeah, this is only one page front and back because we can do some work to adjust it to what we need. This could have been like 5 volumes of z-score shit, but I don't want that. I don't care if you want it because I don't want it. Okay, so what z-score do I want to look up to double check? This is supposed to be 16% below this. So I want to look up -1.00. So how does this thing work? Be on the negative side, right? Negative 1.00. This is the second decimal. Negative 1.00. And what does 1587 round up to? 16. Kick ass. Okay, maybe. So another way to look at this chart is it is the empirical rule, 68, 95, 9%, on steroids, or whatever your favorite choice drug is. Because it just fills in most of what's in the middle. So let's do another example, just to see if everybody sees how this thing works. I need paper, you can do it, Jeff. Here's some paper. Yes. So watch this. What if I want to know, so let's say I have a normal curve. And when I say standard normal, that means they're already z-scores. If they're not z-scores, do we have the way to change them into z-scores? Yeah, we got the old z-score formula. So that's going to become huge now again, a z-score formula. So, but if I say standard, there are z-scores, what's the probability that some z-score is less than 1.07? Let's see if you can look that up. So if you draw it, where's 1.07? Now here's a huge thing. The picture is supposed to help you. I get people, now why did I put a 0 right there? Because, why? The mean will always have a z of 0 because the z-score is the distance away from the mean, standard deviations, right? So it's 0 away from itself. So where's 1.07 go? Up here, please, dear God. Right? And which way am I going to shade? For the question, which way am I going to shade? Yeah, down. The way that's pointing. Okay, I like it. So that's what I'm looking for. Does anybody think they have the answer? So when I look on the positive side now, 1.0, so here's 1.0, 1.07. You guys get that? What is it? Yeah, 8577. Now you guys see why I was making you do probabilities out to 4 places. Just so you're used to the chart already. Look at that. There's a purpose to almost anything I do, except for when there's not. 8577. Done. Sweet. I like it. All right, so let's do the first level adjustment that you have to make. What is the probability that z is greater than negative 0.14? Try to draw it out first. Shade in the area once and see what you can do. I really want to reiterate this. The chart is taking the place of the area formula we did for uniform. Right? That's what the chart is doing. It's giving me the answers for the areas. I just have to look in the right place. If you have a lot of trouble drawing the curve, one semester I had a student, I just said, just freaking make a triangle. You just need some visual anchor that you can put stuff in. Where's negative 0.14 go? Where? Back here somewhere. So like negative 0.14. Which way am I going to shade? Oh, I like it. So real quick, some of you already know the answer, but from the image, how can you tell that it should be more than 50%? How is it more than 0.5? Because what percentage is above the mean? The mean cuts it in half, so what percentage is above the mean? 50%, and this is going to be a little bit more. So I already know the answer should be more than 0.5. So So if I make a mistake, I know I made a mistake. What do you get when you look up negative 0.14 though? Negative 0.14. I get 0.4443.
Well,
You just said it has to be over 0.5.
Say again, sorry.
You just said it had to be 0.5 or more.
Ah, yeah. Oh, look at that shit. Ooh, I like it. Ooh, Jeff made a mistake. No, he didn't. Where's that go? I'm sorry, I got way too excited there. What the chart always tells me, areas where related to what I just looked up. Below it. So where's that go on the chart? This area is 0.4443. Is that the answer to the question? Nope. Sorry, guys. Good point, though. I appreciate that. Keep on coming, because sometimes I make mistakes, for sure. Not that time. So what's the actual answer going to be? 5557. How did you get that for the people that don't know? 1 minus that. That's what I've been building you up for, isn't it? If I know the opposite of what I want, I do 1 minus to get what I want, which is bigger than 50%. Kick ass. So that's beautiful. That's why, that's what I want you to say to yourself in a problem where you forget to do 1 minus. You're like, wait a minute, that's less than 50%. Oh shit, I forgot to do 1 minus. It's like I planted you guys. Okay, maybe. Not too bad, right? And again, the chart is just replacing where I would do length times width. And I can't do that here because this is not a freaking box anymore. It's a box that's been out in the rain or something. All right. So let's do one more type, and then I gotta, believe it or not, I've got a handout. What about this one? You're gonna like this one, even if you don't. 1.92 up to 2.81. Try to draw the picture. Try to figure out what the hell you're supposed to do. By the way, I just want to tell you guys I appreciate that. I mean, I got a pretty high amount attendance rate, so I appreciate that. All right, just want to tell you. So this one is different. The chart